Hello, welcome back to Digital Urim. In the previous video, you learned how the kernel controls the system, how user space works, and how system calls allow programs to interact with the operating system. But now a critical question appears, a question that defines the real security of a system. Who is allowed to perform actions inside the system? Can every user perform the same actions? Or are there different levels of power, levels that determine who can make critical changes? Today, we will explore one of the most important cybersecurity concepts, users, privileges, and the root user. Because in real-world attacks, attackers rarely begin with full control. They start with limited access, and then they escalate. When we hear the word user, we usually think about a person. But inside an operating system, a user is not a person. A user is an identity recognized by the system, an identity that has permissions, and an identity that runs processes. Every time a program runs, it runs on behalf of a user. This is fundamental, because the operating system does not allow every identity to do everything. Each user has limits, restrictions, defined privileges, and those privileges determine what actions can be performed, and what actions cannot. Now connect to security. Imagine this scenario. An attacker gains access to a system, but enters as a limited user. That means the damage potential is also limited. But if the attacker increases privileges, the damage potential changes completely. This is known as privilege escalation, and we will explore that soon. Now let's observe this directly in a Linux system. In this case, Kali Linux. I will open the terminal and execute a simple command, Huami. This command displays the current user. In other words, the identity currently executing commands. This result tells us who is active, but we can go deeper. Now we execute ID. This command provides more detailed information. It shows user ID, group ID, and associated groups. This is important because in Linux, permissions depend not only on users, but also on groups. And groups define which files you can read, which programs you can execute, and which configurations you can modify. Now something very important. In Linux, there is a special file, cat/etc/password. This file contains the list of system users. Each line represents an identity. Each identity represents an access level. This is what allows Linux to function as a multi-user system. Now let's talk about the most powerful user in a Linux system, the root user. Root is a special identity. It has complete control. It can modify critical files, install software, remove configurations, change permissions. In other words, root has unrestricted access. Now we execute sudo l. This command shows what privileged actions a user can perform. The sudo command allows users to execute commands with elevated privileges. This means even a normal user can temporarily gain higher privileges, if the system allows it. And here we discover one of the most important concepts in cybersecurity. You do not always need to start as root. Sometimes, you only need to find a way to become root. Now let's observe the same concept inside Windows 11. We open PowerShell and execute Huami. This command displays the current user, exactly like in Linux. But Windows also allows us to list system users. Now we execute net user. Here we can see all accounts in the system, standard users, administrative users, internal system accounts. This demonstrates something important. Windows is also a multi-user system, and each user has specific privileges. Now let's observe something even more important. Privileges. We execute Huami/private. This command displays the privileges assigned to the current user. Here we can see which actions are allowed. Some privileges allow changing configurations, managing services, accessing protected resources. And this is critical, because privileges determine the real power of a user, not the username, not the account label, the real power. Now let's imagine a real-world scenario. A user receives a file by email. The file looks legitimate, but it contains malware. The user executes it. The malware enters the system, but it enters as a standard user. That means it does not have full control. It cannot modify system files. It cannot change critical configurations. Not yet, but the malware does not stop. It searches for vulnerabilities, misconfigurations, weak permissions, and if it finds an opportunity, it attempts to escalate privileges. If it successfully becomes administrator or root, then the system is fully compromised. This is exactly how many real-world attacks occur. A very common mistake is believing that using a standard user account guarantees safety. But that is not always true. If the system contains vulnerabilities, if permissions are poorly configured, an attacker can elevate privileges. And once privileges increase, the risk increases dramatically. A cybersecurity analyst always asks a critical question: who executed this action? Not only what happened, not only when it happened, but with what privileges did it happen? Because privileges determine impact, and impact determines risk. Today you learned that not all users have the same level of power. You learned that privilege levels define real system security. But now a new question appears. How does an attacker escalate privileges? How does someone move from standard user to administrator or even root? That is exactly what you will learn in the next video. Privilege escalation: how attackers gain full control. Understand, defend, grow.